Welcome to solverfy.
Hi guys, let's solve problem 5.69. If 40 gram of mercury oxide is heated in 502 milliliter vessel and 20% of mercury oxide decomposes, then what is the pressure of oxygen that forms at 25 degrees Celsius? First of all, write down the balanced chemical equation. And now we see that only 20% of mercury oxide decomposes. Therefore the amount of mercury oxide decomposes is 40 gram multiplied by 20%, which gives 8 gram. Now we can calculate the number of moles of mercury oxide involved. Number of moles equal to mass divided by molar mass. The mass is 8.0 gram and molar mass of mercury oxide is 216.59 gram per mole, which gives the number of moles of mercury oxide is 0.0369 mole. Now from the balanced chemical equation, we see 2 moles of mercury oxide decomposes to give only 1 mole of oxygen. Therefore the number of mole of oxygen produced is half multiplied by the number of mole of mercury oxide. Let's calculate that. Which gives us 0.01845 mole of oxygen. Now we need to calculate the pressure. From the ideal gas law, we know PV is equal to nRT, or pressure equal to nRT divided by volume. It's given that the volume of the container is 502 milliliter and the whole volume is being occupied by oxygen. Let's convert it to the liter unit, and temperature is 25 degrees Celsius. Let's convert it to the Kelvin scale. Now we can insert all the information in this equation to get the pressure. Which gives us 0.899 atm. Therefore the pressure of oxygen that forms is 0.899 atm.